because it's just such a different question than what we're necessarily used to. So for A, it asked us to write a tangent line at the point P, and it had told us that the point P was 2. So anytime we're seeing tangent line, really we want to be starting off with x1, y1, and m. So x1 was 2. And then to get y1, we have an equation. So we would type in, or write really just 2 squared equals -2 plus y plus 5 cosine y. And then what you guys would do is you would use your calculator to solve that. So do you guys need me to go over how to do that on the calculator, or were we okay getting an answer? You should have got y equals 4.928, like 4 if you round it. Okay. Always 4 decimals for rounding. And I didn't hear, someone was speaking, I didn't hear what they said. Okay, so for rounding, the reason I tell you guys to go to 4 decimals is that on the AP exam, they're going to look to 3. So if you rounded this wrong, at 4 decimals, it should have been a 4, but if you had left it as a 3 because you just chopped it off, then you still get it correct. If you want to go all the way out, you can go all the way out. So we got 4.2984. And then for m is dy dx. So now we're going to use both of those, 2 times 2 times 1 minus 5 sine of 4.2984, or 9284. And one thing I do want to show us on the calculator, yeah, I wrote this backwards here, 9284. Thank you, Cassie. One thing I kind of do want to make sure we're good on the calculator with is that when we're using our calculator, so we do the solve button, 2 squared, oops, 2 squared equals -2 plus y plus 5 cosine of y for that first question, and then comma y. I have all of this.
You put that all in the exponent?
All that in the exponent. So that's something you definitely want to be careful of. Equals -2 plus y plus 5 cosine of y, comma y. And then we can do an at y is less than or equal to 11, because that was the initial condition. So control equals at y, control equals less than or equal to 11. So this gave us multiple answers. It gave us 4.9283. It also gave us 8.431, and it also gave us 10.05. How do we know that? Why didn't I use all 3 of them? Like, why didn't I pick all 3 of them and make 3 tangent lines? Why did I only pick 9284? Yeah, Cassie said because of the graph. So they're asking us for this point P. So they're talking about this point P, which is right here. And if we look at the graph, that's hitting somewhere at 4 point something. Right? If you notice at 2, it does hit around 8, and it does hit around 10. And those are the other points that it was giving us, but those are not point P. Right? So some questions might say write all of the tangent lines where x is 2, and then we would have to include all 3 of them. But this didn't do this. This just said point P. So we're looking at the graph to figure out, hey, which one of those 3 was it? And then when we're plugging in for dy dx, the safe thing to do, control divide gives us this. The safe thing to do would be to do 2 times -2 divided by 1 minus 5 sine. And instead of retyping it, what's a lot safer is to come up here and just highlight it and go with control C and control V. And the reason that's just a little bit safer is sometimes, not always, and we can even just test it here, but had we just gone to 4.928, you'll notice some of these decimals at the end getting different. Now in this case, it didn't really matter, but if we do look at like the 4th decimal, which is where I've been telling you guys, around 6797 versus 6798, and so that 4th decimal is off. Now, like I said, they're going to grade you to the 3rd decimal, so we're going to be okay, but it is something just to, you know, it's better when you're using your calculator, right? You only ever round it when you're writing it down. But when you're using your calculator, it's better to basically never round. So we wouldn't use that. We would have used that entire 4.9873, as much of it as we could. Okay, so that was our slope. So dy dx was, we said negative 0.679831.
It's not negative.
It's not negative. I somehow got a negative because I put in a negative 2 there. I don't know how I got a negative 2. So 0.679831 goes in for our slope. Or we can stop it at 8. That's 4 decimals. And so then it wanted the equation. So our equation, we're just going to write it as y minus, and again, just go to 4 decimals, 0.6798 times x minus 2, and that's our equation. Okay. So hopefully some of you guys got that. For B, if you guys went on to B, it says find the y-coordinate on the graph where the line tangent to the graph is vertical. So it's asking the line tangent to the graph being vertical. And again, they only want the y-coordinate, and we'll see why that is. Again, no pun intended on that. But I still like to write x1, y1, and m. Cassie, you don't have to box your answer on the test, no. It really just depends. If you have something like write an equation for the tangent line, I might box it just because it's such a specific thing and you have so much work. But on other questions, you definitely don't need to box it. Especially like the explanation questions, you wouldn't box it, like if it's saying to justify. But it is always nice if you have like specific answers to box them. It just makes it easier for the grader to find. But there's really no need to do it or not do it. So when we have x1, y1, and m, for you guys who started this question, what can we fill out right now? What can we kind of start with here? So they didn't give us an x1, they didn't give us a y1. They only said that the point tangent to the graph is vertical. What does that tell us about the equation? What does it tell us about its slope? It's not m is 0. Its slope is dne. So I saw both of those answers. Tangent horizontal, this is something we want to kind of memorize. When we have a tangent line that's horizontal, that means slope is 0. And we have a tangent line that's vertical, that means that the slope is dne. I am going to try to get like a one-pager of notes together just of some of this stuff that we may want to kind of have when we take the test, because it is going to be open notes. So that might be something we put on there. But that's definitely something that if you have memorized, then it's even faster, right? So we see that the tangent line is vertical, okay? And that means slope is dne. The way we get dne on this then is that we have to set the denominator to 0. So if it was 0, right, horizontal, we would set the numerator to 0. But because it's dne, then we're going to take the denominator and set that to 0. So 1 minus 5 sine y equals 0. And like you could put dne here if you wanted to. And then what we'll do is on our calculator, we'll again hit that menu, algebra, solve, 1 minus 5 sine of y equals 0, comma y. And then outside of it, we're going to do control at y less than or equal to 11. Okay, and we got something kind of nasty with these n1s. And when we look at our graph, okay, we can kind of see that the graph, the lowest value on the graph is -1. So that's our lowest value on this graph is -1. And the reason we're getting these weird n1s is because technically a sine graph goes on and on forever. And so because that's happening and it's going on forever, we're getting more answers. So what I'm going to do is I'm actually going to cut it off at -1 because that's where we had it. And so now we're getting these answers, but again, they don't look quite right. So we're going to hit Control Enter to make them into decimals. And now this does get a little bit weird. There are 4 answers, and I'm going to talk about them. Let's write them in first, though. So 0.2013, 2.9402, 6.4845, and 9.2234. Now, one of these is actually not an answer, and this was kind of a neat question. But whenever you get an answer, it is good practice to kind of try to plug it back in or double check that it works. So when we're looking at the graph, 0.2 is about here. That's vertical. That's vertical. Then the next point was 2.94. At 2.94, it actually looks like the graph doesn't exist. So 2.94 actually is just not an answer. And 6.484, so at 6.4, it does look like the graph is vertical, or has a vertical tangent. And the last one was 9.223. At 9.223, again, it looks like the graph has a vertical tangent. So all of those other points worked, but that 2.9 did not work. So our answer is just those three. That one was definitely a little bit tricky with that. It was also a little tricky on the calculator, making sure that we had this -1 here. And that's just something that anytime you're using sine and cosine, just try to get like a minimum and a maximum at, otherwise you're not going to get an answer. And so they might have given it to us, or in this case for the -1, we just kind of had to look on the graph. You could use -2 also, as long as we're just double checking our answers with the graph. Okay. C says find the average value of the x coordinates of the points on the graph in the first quadrant between 5 and 9. So find the average value of the x coordinates. And this is kind of weird, but it's average value formula, but not of f of x, but of the x coordinates. So when we look at our equation was -2 plus y plus 5 cosine of y. And if we just want the x coordinate, then we need to solve for x. So we're going to square root this, because essentially what it's asking us for is between y equals 5 and y equals 9. So average value formula is 1 over 5 minus 9. Integral from 5 to 9. And essentially it's wanting x, but it's wanting x with not dx, but with dy. And the way we know it's dy is those endpoints are y endpoints. So you wouldn't have necessarily needed to write x here. I'm kind of writing it to show us, because we don't want an x. We want something with y's in it. The problem was the formula that they gave us was for x squared, so we needed to square root it to get -2 plus y plus 5 cosine of y dy. Now, this question was worth 3 points, but what I do want to point out is that's a point. So even if you're totally confused, like you read this question and you have no clue what you're supposed to actually set into the integral, you could have still gotten a point just because, hey, I see average value. Let me at least write 1 over 5 minus y, or 9 minus 5, integral. I totally wrote this backwards, huh? We should have written 1 over 9 minus 5. There we go. So as long as you had just written that 1 over 9 minus 5 integral from 5 to 9, you got a point. For the rest of it, you would just type in your calculator. I'm not going to bother with that. Just make sure when you type in your calculator that you multiply the 1/4, right? So you would type in 1 over 4 integral 5 to 9 of that into your calculator, and you should get 2.550. So this was definitely a stranger question, but I want to do as many as we can, look at the weird ones, talk about them, because if we can do all of these, we've seen all of these, when we get to the exam, it's going to be that much easier for us. So there's that. I do want to look through some of the other questions on this exam, like I said. So what I'm going to ask for you guys, just so that you're thinking and I'm aware that you're thinking, is if I have some questions, either have your mic on, if you're comfortable with that, or just type in the comments. And I'll ask some questions on some of them, other ones we'll just kind of speed through. So this number 1 was a calculator question. At time 0, a tank contains 100 liters of water. And they give this piecewise graph. And they give units in liters per minute. And it says water is being pumped into the tank during this 55-minute period. Find R prime of 45. So if we want to find R prime, that's our derivative from the graph. Right? Anytime we're finding a derivative from a graph, that's our slope. And at 45, right, we don't know any y values here, but because it's linear, we can use these 2 points. So you can either use rise over run, and just kind of count down, or you can do f of b minus f of a over b minus a, right, y2 minus y1 over x2 minus x1. Just make sure you don't flip these. A couple people did that. If you use 0 first for the y's, then you need to use 55 first for the x's. You can't just say, oh, I'm going to use 30 because it's bigger and 55 because it's bigger. You'll get a wrong answer. So we get -30 over 20, and you can actually leave your answer just like that. But if you want to make it -3/2, that's a little bit better. Okay, and then you don't need to put the units here because you're going to use them when you explain, but if you want to put them here, you can as well. The units were liters per minute, so when we take the derivative, we're going to add on a per minute, right? Integral chops it off. Average value, it stays the same. So one more time, derivative adds a per time. Integral or Riemann sum chops off a per time. And average value, not average rate of change, right? Average rate of change is derivative. Average value, the units stay the same. So in this case, we were doing a derivative, so it's liters per minute squared. And it says using appropriate units, explain the meaning in the problem. So what R was already the rate, okay? So when we take the derivative of the rate, you might want to say the rate of the rate, okay? So you could say something like the rate of water pumped into the tank at time equals 45 minutes is -3/2 liters per minute squared. Or you could also just say instead, a perfectly fine answer would be, you could say just the rate once, the rate of water being pumped into the tank is decreasing by 3/2 liters per minute squared at t equals 45 minutes. You could say changing with negative, but notice that if I use rate of the rate, right, rate of the rate, then I'm just saying what it is. If I just say the rate of water, then I'm going to use a word like decreasing. So just make sure we're familiar. Either way, you're going to get the right answer there. Okay, B, how many liters of water have been pumped from 0 to 55? And it just is saying pumped into. It's not saying how many are there. So we're not going to add on the 1,000. We just want to know the change. Exactly. So we just use the in rate, right? So like kind of thinking like our like total amount. A lot of times we say is like the amount at some time t equals the amount at some time 0 plus the integral from 0 to time of like the rate in dt. We don't want that whole formula because we just want the in part. So we just want the rate in part. So in this case, all we want is the integral from 0 to 55 of r of t dt. And then we have geometry. If you guys know the trapezoid formula, you can use it. But most of you guys, I feel like, have just been wanting to kind of break these up more this way. And we know this is at 35 because it gives us 35. So we have 2 rectangles and 2 triangles. This rectangle is 20 times 10, so that's 200. This rectangle is 30 height and 15 width. So 30 times 15 is 450. Okay, 20 height. Now 20 width for the triangle 1/2 times base is 20. The height is not 30 because it's just this difference. So the height was 20. So that becomes 200 for that height. And this one is 1/2 times from 35 to 55 is a width of 20 and times 30. So this is 300. So we'll just kind of do that. This is, we'll add all of those numbers up. 200 plus 200 plus 450 plus 300. And then we get 1150. Now, it said how many liters of water. So you don't need to report units because they basically told you what they were. But if you want to just write that word liters, you can. Again, it was liters per minute. We took an integral, so it chops off the per minute. C, at some time 0, or sorry, at time 10, water begins draining from the tank at a rate modeled by the function d, and it gives you d. Water continues to drain at this rate until time 55. How many liters of water are in the tank at time 55? So this is where we want to say, okay, the amount at time 10 is equal to the amount at 0 plus the integral from 0 to 55 of the rate in dt minus the integral from 0 to 55 of the rate out dt, which we can kind of call this. So at time 0, we had 1,000, right? 100 was the starting point. So at time 0, 100 liters are in there. Plus the integral from 0 to 55 of r of t dt, which is what we just solved for, minus the integral from 0 to 55 of d of t dt. You need to write d of t, or you can actually write out that equation. Now, I don't really see anyone being able to get this question right if you couldn't do part B, but it might happen. So if you got this, but you just somehow couldn't figure out part B, just make up an answer, call it 100, and you'll at least get partial credit. But anyways, what we would do is we would do 100 on here. Plus, now we don't have to write that integral here, right? Because for r of t, we don't have an equation, but that's what we just solved for. So the answer was this 1150. So plus 1150, and then minus, and then we're going to go to this kind of little thing next to the book, grab our integral, and from 0 to 55 of d of t was 10, and then we're going to use the e button, e to the power of, we'll use trig, sine of t over 10, and dt. You could have used x's as well. And we get 697.644. So did I mess that up? Oh, I did mess that up. Yeah, I made a mistake, and actually I made the mistake when I was writing this. This is kind of a common mistake a lot of students have made, and so it's a good thing I made. I want you guys to read the question and see if you can catch my mistake. Yeah, endpoints. Why, Cassie? Yeah. So it says at time 10, water begins draining. So I put a 0 here. That's actually not 0. That's actually 10. Because it doesn't start draining until 10. So that's definitely a common mistake that can happen, right? It's just really about going careful, making sure we're looking exactly what they're giving us and writing exactly that down. So I kind of jumped ahead because we're so used to this formula. But we just need to be careful. And I even wrote A of 10 here. I don't know why I wrote A of 10 here. We're solving for, I think I wrote 10 because I saw that. And I just got in this habit, right? But what are we solving for? We want to solve for time at the amount at 55. So we're looking for the amount at 55 would actually be the amount at 0 plus the going in from 0 to 55 and minus the going out, but it's not 0 because it doesn't start going out until 10. So when we change that endpoint to 10, we get the amount at 55 is equal to 799.725, and then that's our answer. Okay. D says using those functions, determine whether the amount of water in the tank is increasing or decreasing at time 45. Okay. This is pretty common, and the more you do of these, the better you get at them. So when we're saying increasing or decreasing, what we're normally doing is like setting it equal to 0 and doing a number line, right? But really, you're just trying to figure out, is it positive or negative? And so if it's at one time, you don't need to do a number line when it's at one time. You never get these on multiple choice, which is why we didn't really do them back in class. And it's something I more go over once we get to some of these questions. But the key is if we ever want increasing or decreasing at some time equals some kind of a number, all you need to do is plug it in. So you're just going to plug it into the derivative and see, is it positive or negative? Now in this case, right, what's the derivative? The derivative is there's a rate in and there's a rate out, right? But the rate already is the derivative. So kind of R of 45 would be the rate in, and D of 45 would be the rate out. So you can either combine them together. All that in blue is just for us to talk about. I'm going to kind of show us two ways. You could combine them together and write R of 45 minus D of 45, or you could just do them separately, one at a time. You could say, let's just first find R of 45, and then let's find D of 45. Either way, you'll get the same answer. So R of 45 we're going to get from our graph, right? And at 45, we don't have a y value. And it's not negative 3 over 2. But we do know the slope, right? So we know that it's going down 3 over 2, down 3 over 2, down 3 over 2. So we can find R of 45 just by kind of counting, right? Or you could even just literally just write the equation on the line and solve for it. So either way will work. So if we were at 30, right, for a y value, down 3 is 27, and over 2 is 33. So we'd be at 33, 27. Okay, again, over 2 is, 37, over 2. 37, 27. Over 2 is 39, and down 3 is 24. Over 2 is 41, down 3 is 21. Over 2 is 43, down 2 is 18, and over 2 is 45, down 3 is 15. So just kind of by counting, I figured out that R of 45 was 15. You could, I guess, try to estimate it, but you're really risking it there. The other way I could have done this if I wanted to was, we know that this is a line, so we can just write the equation of the line, right? Y minus y1, I'll use 30, equals, the slope was negative 3/2 times x minus x1, and we'll use 35. It might have been smarter to use 55 and 0, so we had a 0, but it's okay. So y minus 30 equals negative 3/2 times 45 minus 35, because we're trying to solve for R of 45. Y minus 30 equals negative 3/2 times 10. That cancels to a 5, and we get y minus 30 equals negative 15. Add the 30 over, and y equals 15. So either way we do that, we get R of 45 is 15. Okay, I know it was a little weird, but just kind of is what it is. And then for D of t, we just have to plug it in. So you can type in 45 here for t. I like to actually just leave it as a t. Sometimes you need it later. And then I like to do the at time equals 45. But in this case, you would have been pretty safe off to just type in 45 for t. And if you get something like that, you just want to hit Control, Enter, get yourself a decimal, 10.8815. So in this case, when we're doing it this way, you might want to just point out that, hey, the rate in is greater than the rate out. That would be acceptable. The other thing you could have done is you could have just kind of done it by subtracting and seeing is it greater than or less than 0. So 15 minus 10.8815 is greater than 0. So either writing that or that is the work. Now you just want to, it says justify your answer, so you want to make sure we explain was it increasing or decreasing, and just kind of write it into words. So because it was positive, or because the rate in is bigger than the rate out, that means that basically that the water is increasing. So we're going to say the water in the tank, right, just use their words, is increasing at, you always need your at, t equals 45 minutes, because r of 45 minus d of 45 is greater than 0, or if we used our explanation in red, because r of 45 is greater than d of 45. So both of those explanations work. I know we took a long time on this question, but I just think it's such an important concept and we haven't talked about those in a while.
For part A, I did k of 5 minus k of 3 over 10 minus 5. And I got 5 over 2.
Okay. So you did k of 5 minus k of 3 over 5 minus 3. You plug that in. And so that's k of 5 is 10. And minus 5 is 5 over 2. And then what about for your units?
Feet per second squared.
Good, feet per second squared, because we're taking a derivative, so we add on it per time. So that's perfect. That's full credit. If you want to, since you're doing acceleration at 4, maybe you write a of 4. And then instead of equals, we're estimating it, so we do approximately. You're not going to lose a point if you don't do that. The main thing is basically you're getting, on this question, they were giving you 1 point for the 5 halves and 1 point for the feet squared, but you're not going to get any points if you don't write this. Now, you don't have to write k of 5. You could have also written just 10 minus 5 over 5 minus 3, and they'll know where that came from. But basically, you need one of those, because they said show the computations. Okay, B, Carlos Garcia, Carlos Cuisine, or Maria. Can one of you guys hop on the chat or on your mic and tell us what you guys did for B?
So we just took the integral from 0 to k of t dt, so we got 191 feet. And it would be an over approximation because the graph is increasing.
Good, so you said it's overestimate. Because I like to always say, not necessarily the graph is increasing, but actually say what's in here. So because k of t is increasing, and then just say Rm. I think we've done so many of these Riemann sums that I'm hoping at this point we don't need to go over how they got 191. But just to be extra safe, right, that's our width is 3, times the right side is 5, plus the width is 2, times the right side is 10, plus the width here from 5 to 8 is 3, and the right side is 20, and plus the width here is 4, from 12 to 8, and the right side is 24. So you add all that up, you get 191. Okay, C, Nathan skates on the same track, starting 5 feet ahead of Kathleen. Nathan's velocity is given by this formula n of t, and write, but don't evaluate, an expression that gives Nathan's distance from the starting line at time 12. So, Brisa, Elvia, or Monse, can you guys answer that one?
So in order to find the distance, we put that, you'd have to do the expression 5 plus integral 0 to 12 of m of t, and we wrote out the actual question.
So you just wrote it out, okay.
Yeah.
And you don't have to write it out. If you want to, you can. Now, why, and so that's perfect. They said expression. Expression means you don't have to have an equals, but you definitely could have an equals. If we had an equals, the equals would be, say, like s of 12, or like distance at 12, or x at 12, whatever we want to name it. But that's kind of optional. This is the main thing. And that's perfect. I hopped in a few of the chats, and it seemed like we had that. Why, when it says distance, why don't we have absolute value here, even though we saw the word distance?
In the condition of that problem, they're just going straight. They wouldn't be going, like, backwards. They're running on a track, and it's increasing.
Okay, so they're going on a track, so they're only increasing. That could be correct, for sure. But even if it was decreasing, actually on this one, we're not going to have absolute value. And it's kind of mean, and you just want to watch out for that, is when you see distance, just kind of double check. This says distance from the starting line. Okay. When we see distance, that's kind of different from position, right? We've talked about this a lot, right? If this is our starting spot and we travel 1, 2, 3 steps to the right, and then 1, 2 steps back, our distance was 5 feet, or 5 steps. Whereas our position, 1, 2, 3 to the right, 2 back, our position is just 1 foot. But if we read the words distance from the starting line, okay, distance from the starting line, actually, which one does that fall into? That actually falls into this. That's the distance from the starting line. So we just want to be careful that position, some other ways they can write it, is they can write displacement, or they can write distance from the starting line, or from the origin, something like that. Okay, now the only thing about distance from the origin is it is a displacement and it is a position, but in the number value will be the same, but distance from the origin, you'll basically do it the same way, but if you get a negative answer, you might turn it positive. In this case, you guys were saying it's a track, so it has to be. And generally on these questions, it will be positive. But just kind of, anytime you see distance, just double check. If you see afterwards from the starting line, you're like, oh wait, that's just position. They're really just asking me for position. It's kind of a mean way to write it, and I wish that people wouldn't write it that way, but they do sometimes. They're just kind of really making sure that we understand the concept, and that we're reading everything carefully. All right, D, Eileen, Carlos Vasquez, Melanie, what did you guys get for D?
You just take the derivative. You would get 50 e to the negative t minus over t minus 3 squared.
Okay, sorry, can you repeat it one more time?
50 e to the negative t.
Okay.
Minus 150 over t minus.
What did you say on the bottom? All right, Carlos, you cut out. I'm assuming you had t plus 3 squared. I think you might have said minus, but it's t plus 3 if we're looking at it. Now, you are missing one negative on this, and this 50 e to the negative t. Because when we take the derivative of... Oh, wait, no, yeah. Okay, it is positive, yeah. That's my bad. So the reason this became positive, and Carlos wrote this, he just moved the 50 to the front, which is great. A lot of times, you put your positive number first. But we were starting off with 150 over t plus 3 minus 50 e to the negative t. So if anyone wants to see this kind of step by step, the t plus 3, you can either do quotient rule on this if you really want to. I don't like to, because there's no t in the numerator. So if there's no t in the numerator, what I kind of think of is, what does this look like? It kind of looks like the y equals 1 over x. Well, the derivative of 1 over x, that's reverse power rule, negative 1 over x squared. So now, instead, we have y equals 1 over box, or 150 over box. So y prime is going to be negative 150 over box squared times the derivative of the box. So that's negative 150 over t plus 3 squared times 1. And minus 50 e to the, again, this is e to the box, so e to the negative t times negative 1. And so the negative 1 and the negative 1 turn this to positive. And then he just moved that here. You also might have just done that on your calculator, and on your calculator they might put the 50 front. It doesn't matter if the 50 is in front or back, it's the same thing. Yeah. So good job with that one. That one definitely was a little bit quicker, for sure. So our next one, so I know how much we love slope fields, being a little sarcastic, but again, I think on our exam, graphs, tables, and slope fields kind of almost count as a graph, are something that are pretty hard to Google. So I'm gonna have them, if you're on phone, I'm not sure I think there's a way to do it on the computer too. I think there's like an annotate button on the computer, but it's probably a little bit harder if you don't have a touchscreen to use like the trackpad. So it's a little bit easier with the phone. So I'm gonna have one of them just use the little pencil button that's, if you click on your screen, it kind of pops up in the bottom left, and just write what they got. Hopefully. Cassie, Montse, Kyra, who was doing it last time? There we go. Good. So the first thing that usually on these are usually worth 2 points. Sometimes they're only worth 1, but usually it's 1 point for all the zeros, which you got. So these ones and these ones are 1 point, and then it's 1 point for the rest of them. And they'll be a little bit lenient. You know, you wouldn't lose the point. Ideally, you want these two to kind of be symmetrical or mirrors of each other. They're not going to lose the point if they're not. You'd probably still get that, be okay. And then same thing with these. If you look at this, this on the right side, so like when we're looking at the right side, you can definitely see that the top one, this top one is steeper than the bottom one. Whereas on the left side, they don't quite look steeper, so we want to really make sure that this one looks a little bit steeper. But you'd still get the points there. Where we did make one mistake was, and you want to kind of be looking out for patterns and just double check your work if you see something that looks off, is on the left side and the right side up top, everything was kind of flipped from left to right. But then on the bottom, these two guys look the same. So I would just plug them back in and just really double check it. So if we plug in, we have x times y minus 1 over 4. So this point here is negative 1 comma 0. That's negative 1 times negative 1 over 4 becomes positive 1/4, which we have this with a negative slope. So that one should have been positive 1/4. So, you know, this one, you guys unfortunately would have just gotten a 1 out of 2 for that, because even if you're missing 1, they might take that off. So I don't know how strict they're going to be on this exam. That's a question that I've asked before, and they've said sometimes if you do have, like in this case, 1, 2, 3, 4, 5 out of the 6, and they could really tell that you knew it, sometimes they'll give it to you. Other tests they don't. It just kind of depends on the year. Okay, so moving on, part B. And it looks like I got presentations. I actually think it'd be really cool if anyone wants to try to volunteer to do part B. You might have to zoom in a little bit to write it well, but I think it'd be pretty cool if anyone wants to try to show their work. I'll be impressed. I'm not going to force anyone to, but if anyone wants to try doing that, Elvia, you volunteer. So you'll click the little pencil. There should be a little pen. Are you on your computer or your phone? I don't know where it is on the computer. Do you guys have like a meeting thing like this on your computer? So like for me, it would be this annotate button. I don't know if this is like at the top for you at all. Okay, so it's okay if it looks funky. We know you're using a mouse, so it's tough. So she got f of 1 is 3, good. And so she did x1 is 1, y1 is 3, and then dy dx, she's using the formula, I'm assuming, to find the m. You can just put the answer, yeah. Good, so 2 over 4, so 1/2. So y minus 3 equals 1/2 times x minus 1, good. Okay, nice, changing it to f of 1.4. You don't have to change it to f of 1.4, but that is nice. The other thing you can do, Elvia, when you change it to f of 1.4 is then make the equal sign an approximately. So I'll help you out there. You got it. Sweet. And you can just jump to the final answer here if you want to. Good. And so 1.4 minus 1 is 0.2. And just, even though we have a decimal and a fraction, just half of 0.2, right? And we'll have a calculator, so we don't have to be too scared of that. But half of 0.4 is 0.2. And then add over the 3. Good. So the two big things here were writing the tangent line, right? It said write an equation for the tangent line. So that's probably going to be worth 1 point. And then use it to approximate f of 1.4. So if you had just done y minus 3 equals 1/2 times 1.4 minus 1 and kind of left it like this, they're still going to give you the point. But changing that over to f of 1.4 and using the approximate symbol really shows them that you know exactly what's going on. So that's awesome. Good work. That was cool. So part C is really just longer and kind of nasty. So I won't ask anyone to do that for part C because it's just kind of nasty. So, oops. Okay. So for part C, whenever we see particular solution or solve, for any of these, that's where we separate. Even general solution, that's where we're separating the x's and the y's, the dy's and the dx's. So times dx, and then divide by y minus 1, because we're dividing out the y part. So over y minus 1 will cancel, and divide by y minus 1. So we get dy over y minus 1 equals x over 4 dx. And if we want to rewrite this, I chose to kind of just rewrite it as 1 over y minus 1 dy equals 1 over 4x dx. To me, that just makes it a little bit easier. You don't have to. And then we will take the integral of both sides. And so on the left side, it's technically u sub, because 1 over, like the integral of 1 over y would be dy. The integral of 1 over anything else, sorry, the integral of 1 over y would be, I don't know what I was saying, would be ln of y plus c. The integral of anything else, we're going to want to do u sub on that. But in this case, when we do u sub, what ends up happening is that our u is y minus 1, and our du is just 1 dy. So one thing that I've told you guys a few times is if you ever get a du that's just 1, that actually means that the u sub doesn't really end up adding anything on. So we can just make this ln of y minus 1. And on the right side, we would get 1/4 times x squared over 2, then plus c. So that's ln of y minus 1 equals 1/8 x squared. And if you want to have x squared over 8, that's the same thing. So x squared over 8 definitely works. And then to get rid of our ln, we're going to do e to both sides. And then I'm going to move this up here. So that gives us y minus 1 equals, and with this e, remember we take the c and we move it to the front. C e to the x squared over 8, or 1/8 x squared, if we want to write it that way, is fine. And then we'll add the 1 over. So y equals c e to the x squared over 8 plus 1, and we're almost done. But then that last step is going to be to just plug in our initial condition. So our initial condition was 1 and 3. So for y, we're going to plug in 3. And for x, we're going to plug in 1. 1 squared is 1. And this is kind of a nasty one to solve for. So 3 minus 1 is 2 equals c e to the 1/8. And then we're going to divide by e to the 1/8. So we get 2 over e to the 1/8 equals c. And so that means our answer will be y equals 2 over e to the 1/8 e to the x squared over 8 plus 1. And that's a perfectly fine answer. And I would leave it like that. Now, what you might see if you type this into your calculator is you might see 2 e to the, so what you can do is, since this is e to the 1/8 in the denominator, and change it to negative 1/8 e to the x squared over 8 plus 1. And then what happens when you're multiplying, right, like x squared times x cubed, when you're multiplying things, the exponents add. So e to the negative 1/8 times e to the x squared over 8, these guys add, and so you get x squared minus 1 over 8 when they add, right? So 2e to the x squared minus 1 over 8 plus 1, that's probably how your calculator would show it. But there's really, if you're doing it by hand, there's absolutely no need to get that far. I'm kind of just confusing you unnecessarily. But I just want to explain that if you did type that into your calculator, like you were trying to solve it on your calculator, that those are the same answer. All right? Cool. Now, because I don't want to spend any more time on this exam, and we're kind of running out of time, I do want to just show this one. We're not going to actually really go over this one on our own, but give me about 5 minutes and then we'll be done for today. Okay, so this was question 6 from this practice exam we've been looking at. Let g of x equal 4 times x plus 1 to the negative 2/3, and let f be the function defined by the integral from 0 to x of g of t. A lot of times we see this question with a graph, but they didn't give us a graph. But as soon as we see this guy kind of here, and actually let me see if I can open it in the other app. Okay, there we go. So as soon as we see this guy here, what I like to do is just somewhere, up on the side, just kind of write, that means that f prime of x would be, plug this in, do chain rule if you need to, g of x, so the original, and f double prime of x would be g prime of x. So that's just something to be thinking about. So A says find f of 26. So again, I'm not going to go through this. I'm just going to kind of look at the answers, make sure we don't have any questions on how we would do this. So f of 26, you're just plugging in 26 to x. So it's the integral from 0 to 26 of 4 times x plus 1 to the negative 2/3. I don't see them asking it this way on our exam. I see it more being a graph with doing area, because really if you got this, all you would need to do is plug it into your calculator. This was a non-calc question, So you had to do this one by hand, but the reason I don't think it's going to be on our exam is our exam, technically you would have access to a calculator. So anything that you just type into your calculator like that, I don't think they're going to give that to us because it's just too easy. B, determine the concavity. So that's a little tougher. Determine the concavity. They're saying is it concave up or concave down for x is greater than 0. So to get concavity, we're checking the second derivative. So the first derivative was g of x. So it's just the equation. The second derivative was g prime of x. So we have to take the derivative of this. So we bring the negative 2/3 down, 4 times negative 2/3. And then when we subtract 1, it's kind of like saying negative 2/3 minus 3 over 3, which is negative 5/3. So if you multiply to the top, you get negative 8. If you want to put that negative up here, you can. Over 3x plus 1 to the 5/3. And this is a little bit weird, but remember they were saying for x is greater than 0. So like on a number line, if we plug in anything greater than 0, 1, 2, 3, 4, 5, this bottom is going to be positive. So this whole bottom side is going to be positive, and the top side is going to be negative. So a negative divided by a positive is a negative. So that means it's concave down. So you'd say it's concave down for x is greater than 0 because f double prime of x was less than 0, for x is greater than 0. You don't have to show it on the number line, but I like to do those with a number line. Technically, the one critical point where this would change would be at x equals negative 1, right? If we set the top and the bottom to 0, you get x equals negative 1, sorry, an inflection point. So it would be concave down for x is less than negative 1, but they didn't ask about that. All right, and then C says let h of x equal x minus f of x and find the minimum value, 0 to 26. So that's an absolute minimum. So to get an absolute minimum, the first step is always going to be, right, we have h of x equal x minus f of x. So the first step is going to be to take the derivative, set it equal to 0. So the derivative here is 1 minus f prime of x. We already solved for f prime of x. And so f prime of x was just g of x, right? It wasn't anything fancy. It was just the formula. So 1 minus the formula, we're going to set that equal to 0. I would just use the solve button on your calculator, honestly. So you solve it, and you get x equals 7 is our only critical point. So then we're going to make a table with 0, 7, and 26, and we're going to plug these back into h, right? H of x was x minus f of x, which becomes x minus the integral from 0 to x. So when we plug these in, right, like plugging in the 0 is just 0 because it's 0 minus the integral from 0 to 0. Plugging in the 7 they did up here, 7 minus the integral from 0 to 7. And again, I would just type that in your calculator. You get negative 5, 26, you get 2. So they said the minimum is negative 5. And I like to always just add on at x equals 7. So that was just kind of a quick one I wanted to go through. I don't think it's going to be asked that way, but it's still good to just review these. Okay? Thank you guys for showing up early in the morning like always. And I will see you guys tomorrow.